to clap. Awesome. All right, so now we get to part where we'll introduce our speakers. Our first speaker is Uma Bhatt. Uma has worked at University of Alaska for 25 years on climate variability research and is currently a professor of atmospheric sciences. She enjoys co-teaching multidisciplinary classes and hopes that someday we will not give grades in classes. She needs to reacquaint herself with her hobbies and as she ponders life a few years from now. So Uma, if you're ready, please go ahead and share your screen and the floor is yours.
Thank you. Let me share and can you see the screen, the slide?
Yeah,
all right.
Good.
Perfect. Yes, looks great.
Awesome, thank you. All right, thank you for this opportunity to speak about the 2022 Sea Ice Outlook and the Sea Ice Prediction Network Phase 2 or SIPN2. I work at the University of Alaska Fairbanks, which is located at Trothiada, the traditional homelands of the Lower Tanana Dene people. The SIPN2 project team listed here at the top and contributors to the Sea Ice Outlook or SIO have created a really unique, strong and vibrant community for seasonal sea ice forecasting. This activity brings together different methodologies of forecasting where the SIO has collected over 100 forecasts of September mean sea ice extent each summer, initialized in June, July, August, and most recently including September from a global community. The methods include heuristic, statistical, and machine learning, which we group together in this plot, and dynamical. The number of yearly contributions has quadrupled over the first 14 years, peaking in 2021. SIPN is really invested in the notion that scientific understanding can get farther by collaborating on our complex problems, particularly sea ice forecasting. The Sea Ice Prediction Network emerged from a meeting of Arctic researchers in the autumn of 2007, shortly after the first extreme low in the satellite sea ice extent record. The goal was to galvanize the community to investigate seasonal predictions of Arctic sea ice. NOAA Arctic Program Manager John Calder suggested a contest to forecast the September sea ice as a way to encourage more research on seasonal sea ice forecasting and to broaden the participation or get more people in the world interested. A bare bones activity began in 2008 until 2013 with small pots of money. In 2014, a National Science Foundation project was funded with Julian Strove and Cecilia Bitz as the PIs. The network grew with new activities like Alaska and Antarctic forecasts. And starting in 2018 was SIPN2, where a portal for spatial forecast data was included. In January 2021, a 1.5-day virtual contributors forum was organized by the SIPN2 leadership team and held. And really the value of the network was demonstrated then. Forum attendees were asked, should we continue this? And they really strongly supported it. So a SIPN3 proposal has been submitted in April 2022, April of this year, and we're waiting to hear. This graphic shows the signature SIO product of ranked ordered forecasts that are colored by method. Statistical is red and dynamical is green. Based on input from our contributors in 2021, we solicited additional forecasts that were initialized in early September. And this is the second year that we've collected September forecasts. And this is the September from the September SIO. The solid gray line shows the observed 2021 value of 4.95 million square kilometers. And the dashed line shows the 2022 September median forecast of 4.91 million square kilometers. Note that the SIO forecasts September mean sea ice, not minimum. And the observed average, like how are we doing? So what I did is I took September 1 through 24, all the data I could get yesterday, and I averaged it, and that the average extent is 4.82 million square kilometers. So it's bound to go a little bit higher once we add 6 more days to the data to get the full month. So this year, the median forecast is actually pretty close, not too bad. These box and whisker plots show the evolution of the June through September SIO. So the first first box and whiskers is June, July, August, September. The red is statistical and the green is dynamical. The horizontal line shows the 2021 observed value of 4.95 million square kilometers. And we see that the medians of both the statistical and the dynamical have increased over the forecast season. Dynamical models show more variability early in the season, and it's really decreased by the time we got to September this year. The average September 1 through 24 Pan-Arctic sea ice extent, as I said, was 4.82 million square kilometers. And it really compares well with the August and September median forecast shown on the right, which were 4.83 and 4.91. So we'll see where things shake out shortly. So NSIDC announced that the Arctic sea ice reached its minimum of 4.67 million square kilometers on September 8th, 2022. And it's shown in the left panel with the 1981 to 2010 climatological extent shown in yellow. The most remarkable feature of this past summer was pointed out by Walt Meyer is the opening of the ice in the high Arctic north of the Kara Sea around 87, 88 north, latitude within 300 kilometers of the pole. Quote, we've seen reduced concentrations up high in the Arctic in previous years, but this is the first year that we've had such notable openings that persisted for so long, from late June through August, though they did close occasionally due to winds. That's a quote from Walt. The opening is visible in the University of Bremen daily image from August 18th, seen in the right panel. So that's one of the more interesting things from this summer. There were lots of interesting things, but I have to limit the interesting things. So now let's talk a little bit about forecast skill. This was forecast skill for June through September for the 2008 to 21 SIO forecast that was constructed by Ed Blanchard Rigglesworth. The plot on the left shows root mean square error by lead month, so June, July, August, September. The dashed line is the damped anomaly benchmark, where a damped anomaly, you initialize it at the beginning of the month and you damp the anomaly to the climatological trend. And it really, the damped anomaly at leads of less than a month, the error is really quite small in the damped anomaly. And overall, the damped anomaly is a hard benchmark to beat. The multi-model ensemble is shown in blue, and it has the highest skill of all the SIOs pieces, and it's followed by statistical in pink and dynamical models in red. The skill improves over the course of the summer. And the plot on the right has the observed sea ice extent on the x-axis and the June median forecast on the y-axis. And it shows that anomalous years have greater error in the SIO. And this is a replot of work that was done earlier by Larry Hamilton and Julian Strove. So the SIO does well in years when the observations are close to the linear trend. It's one thing we've learned. Now we have 2 years of early September initialized forecasts for September mean sea ice extent. And the plot on the left shows the observed 2021 daily September Arctic sea ice in the black line. The colored lines are the possible spread of where September 1 initialized extent could go based on observed daily tendencies from different years. And the bluer years are earlier years, the redder years are more recent years. Might be a little bit hard to see depending on your screen. The colored dots on the right under the heading September mean show the September mean from those different scenarios. And the black dot is the observed. The final column of black dots is based on the SIO September forecasts in 2021. So in 2021, what we see is most of those forecasts were well below the possible scenarios based on observational trends over the month of September. The plot on the right is the exact same plot, but for 2022. And the black dots show the SIO spread has many more forecasts that fall within the range of possible scenarios. So did we do better due to improved forecasting, or was it chance? So this is something Ed is looking into further, and we'll have to figure that out. Another additional activity that emerged from the forum was collecting anomaly forecasts in order to explore whether the large spread and errors came from model mean biases. And really a big caveat in these collections is that we kept the definition of anomaly based on each contributor's own baseline in order to maximize participation. We didn't make it too strict, like didn't have particular years. And this plot shows observed September sea ice extent and a trend line from 2005 to 2021 as a dash line. And the lower plot shows observed anomalies off of that trend line. So you can see that, what the anomalies have looked like over the last 15 years. Now, this plot on the left shows the anomaly forecasts for June, July, August, and September of this year. And this activity really was collected in order to explore whether the large spread that we're getting and the errors come from model mean biases. So if we get rid of the model means, do we decrease the error? And the answer is no, we don't. And what we find is that over the summer lead time, the forecast leaned more positive, and the medium anomaly forecast was 0.17 mean million square kilometers in June. You can see on the right, and then it grew to 0.695 in August, and then was 0.6 in September. And now if we do the same thing as I did earlier, you take the average observations of the Pan-Arctic anomalies from September 1 through 2004, September 1 through September 24 of this year, you get 0.44 million square kilometers. So the forecast will likely be a bit higher than what we see. Now, the contribution history for forecasts of Alaska seas that consist of the Bering, the Chukchi, and the Beaufort shows an increase in statistical methods over time and kind of an average of 30 contributions over the most recent years of SIPN2. And the SIO medians for the 2022 Alaska forecast are shown in the right panel, and they increased until August, and then it decreased again in September to 0.49 million square kilometers. And the observations, the observed sea ice from September 1 through 24 for Alaska was 0.45, just slightly lower than the September forecast. Once we add a few days, that's likely to go up a bit. Now, the observed history of the Alaska seas is shown by the orange line, and a smoothed cubic fit is shown also by the dash line. And this also is kind of a busy plot, but it shows the SIO forecast for the different months shown by different shapes. And the forecasts were really quite good in 2017 through 2020. And in fact, we're doing better in these Alaska seas than we are Pan-Arctic. It was strongly underestimated in 2021. We didn't get that positive anomaly. And this year, we're likely to be fairly close for the September initialized medians, which was 0.49, as noted in the last slide. And really, the reason for doing the regional focus is this is where sea ice forecasting really connects to stakeholders. Kind of our single metric might be interesting from a more intellectual and theoretical point of view, but if we're if we want to make products that are useful, you got to look regionally. Another regional element is the SIO's SIPN South that forecasts Antarctic sea ice, and this is led by Francois Massonnet from University of Liège. This forecast activity is nascent, and the 2022 forecast spread is large, as it was last year in June through September, compared to interannual variability. In September, the persistence forecasts and 5 of the 7 forecasts predict a negative anomaly relative to the climatological value. And I don't know exactly where this stands, so I can't tell you how this is doing. So the 15 years of SIO has shown that the skill is lower than expected from more theoretical studies. And this motivated an apples to apples comparison of SIO retrospective forecasts for mean September sea ice extent for a common period going from 2001 to 2020. This work is being led by Mitch Bushhook of GFDL, and contributors have provided 17 statistical, 16 dynamical, and 1 heuristic prediction. And this will really allow a clean comparison using the same forecast system, right? Over the SIO, people's forecast systems have changed. So got to be a little bit careful there. Again, a clean comparison using the same forecast system over the 20-year hindcast. And this analysis has already revealed interesting insights that Mitch and Ed will be speaking to you about, I think, in an upcoming sea ice team meeting. And the idea of this type of comparison also came from the contributors at the forum. So again, this group working together really is a way to push the science. Over the course of 15 years, the Sea Ice Prediction Network has strengthened and developed to highlight some common features of seasonal sea ice forecasting that might not otherwise have been evident. And why is the seasonal sea ice seasonal skill lower than expected from other studies? And when considering next steps, an upgraded portal where people can collaborate would be really nice and would really help push the science forward, as well as answer other questions. Looking forward, a focus on regional evaluations and additional seasons would build our knowledge on sea ice forecasting. The community is considering a multi-model weighted forecast based on past performance. And I know it's sometimes very hard to compare forecasts. And a forecast may not do well, and another forecast may do well, but there's two goals. One goal is to make the best possible forecast we can. And then the other goal is to understand where our strengths and weaknesses are with the forecast. So the good forecast and the bad forecast both contribute to the latter. They really do improve our understanding, because you may be getting good forecasts for the wrong reasons. So again, I don't know how to say this, but forecasts that don't do as well can be very insightful and really help move our science forward. And, there are, of course, challenges in any community network. Contributors are volunteers, so demand should be limited, and the network must really create a space to foster true collaboration. The Sea Ice Prediction Network is doing its best to create a community where working together is the preferred choice. Thank you for your attention.
Thank you, Uma. That was a really nice overview of those activities. We have time for 1 to 2 questions for Uma, and then we'll switch over to Rick's presentation and have a longer discussion after that. But I want to open the floor for anyone that might have a burning question. And don't be shy. Give 1 more minute, because I have a question, but I want to make sure others have opportunities. Okay, so Uma, I have a quick question, and this might be my lack of familiarity with forecasts, but you said that the anomalies grew more positive with the seasons, and do you have any ideas why that is?
So sorry, I should have the anomalies became more positive they became more positive, the forecasts. Sorry, the forecast anomalies became more positive as the lead time reduced. That's how I should have said it.
Okay,
so I meant the SIO season. So cool. as we got closer, they got better, and we're closer to what we're getting. So
okay, that connects the dots. Thank you.
Bad
no, it was good. It was my slow brain. Okay, if we don't have any burning questions now, how about we move on to Rick's presentation, and then we can have this longer discussion collectively. Rick, are you ready? And thank you, Uma.
You bet. Thanks, Melinda.
All right, I'll introduce Rick quickly. Yeah, Rick has worked for 40 years in the weather and climate enterprise in public, private, and academic venues. Following a 30-year career with National Weather Service Alaska Region, he now works as a climate specialist with the Alaska Center for Climate Assessment and Policy at the International Arctic Research Center at UAF. One fun fact about Rick is quite fond of Scottish bagpipe music. Take it away, Rick.
All right. If I was technologically savvy, I would try to have some intro bagpipes here, but I'm not, so. All right, so thanks for joining, and thanks for the invite to talk to you. So it's sea ice around Alaska this year has been quite interesting. It always is, but maybe this year even more interesting than usual. So I got this is just my grab bag of things to present here in 15 minutes to you. Some of you will be familiar with most of this, others might be new. So start out here with talking about sea ice in the Bering Sea in the spring of this year. Really quite an interesting story, I think, both from the science side and from the impacts to communities in the region. Second up, we had the strange case of we actually got ice in the Bering Strait in August for the first time in an age, and that's kind of interesting. And then I didn't know I was going to talk 2 weeks ago, but just thought I'd finish up here with a couple of slides here on ex-typhoon Merbach, which of course severely impacted the Bering Sea coast, some but lesser impacts on the Chukchi Sea, southern Chukchi Sea coast, and what that did or didn't do to sea ice. All right, so here is my plot of the daily sea ice extent for last season. That's in blue. Green line is the year before. Thick black line is just the smooth 30-year median, and all the other years there underneath. So if you just look at that blue line relative to the 30-year median, overall, it looks like a pretty decent season. We had extensive ice early in the season, closer to normal there around New Year's during the very stormy December that we had across the region. But most of the kind of the midwinter period there after New Year's, ice extent was above normal. Some variability, which of course is not unusual in later February and March. And then if you look close there, really quite a dramatic drop during April in ice extent. But overall, it looks like it was a pretty decent season for ice, as these things go these days in the Bering Sea. And if we just take a look at the sea ice concentration here, now the two graphics here are one, on February 15th was actually from the NSIDC sea ice index. This was the date of the highest sea ice concentration in the Bering Sea. You can see there we've got ice in Bristol Bay, west to St. Paul, not quite to St. George, and then northwest to the Chukotka coast, and then beyond the Weather Service analysis here continued down a ways along the Russian coast there as well. The graphic on the far right there from March 28th, that's actually, I put this up because we had lost the ice in Bristol Bay for the most part, so we didn't quite get back up to the February 15th maximum, but we did get ice to St. Paul, or I'm sorry, to St. George, past St. Paul. And that's the first time we've had ice to St. George since early April 2017. So if you just look at these, oh gee, looks pretty impressive. It's not at the level of spring of 2013 or spring of 1976, but pretty decent ice extent. But at the same time, the ice is real far south. There is lots of things going on in the northern Bering Sea, and this is just some community pictures in February and March there. And what I want to call your attention to here particularly is on the bottom panel there with on the bottom left there is the view from the helicopter approaching Diomede, and then from fixed wing aircraft there in the last week in March approaching Gamble. And these pictures to me are particularly stunning. That Gamble picture, I mean, that looks like you're on approach into Anchorage. That gray ice. This is March 25th. This ought to be nice, bright, snow-covered ice at Gamble, and it looks like it's Cook Inlet ice. Of course, open water offshore of Gamble happens, but it seems like it's happening most every winter, not just in April now, but throughout the winter. And a little bit of shore-fast ice there in the upper left there. Couple hundred meters worth of shore-fast ice at Unacleat, but open water to Beesbow Island there. So really, it did not look so good from the community's perspective in the northern Bering Sea. And elders in particular on St. Lawrence Island were talking about very poor ice quality all winter long, describing it as we had fall ice right through midwinter and into the spring. So a very different story than, oh, gee, the ice is all the way to the southern Pribilofs. So here's a little bit more in detail. So using AMSR2 here, I looked at, okay, when was there at least 2 days of open water during the month of March from AMSR2? AMSR2, of course, the higher resolution passive microwave. And I picked 2 days here just to avoid the pixel noise problem of 1 day. So you had to have 2 days to get here. And you can see some of this stuff is, of course, routine features, the open water there southwest of Utqiagvik, the Polinia south of St. Lawrence Island. Those are standard features, but the fairly large area there of north of Nunivak Island, the YK Delta area there, had at least 2 days with open water. The majority of Norton Sound at some point was open. And if I would have picked a little bit higher threshold, instead of 15% concentration, if I'd have picked 30, so a lot of water showing, that would have encompassed all of Norton Sound. So really quite a lot of evidence here for really something different going on in the northern Bering Sea that we saw from those photos and heard from the communities at the time. So one of the tools that I've been excited to use the last few years, we've got now 12 records of the combined SMOS Cryosat-2 ice thickness data. And so I ginned up this graphic here. So this is just the percent of median ice thickness here. Now, of course, obviously, we don't want to make too much of 11-year climatology. On the other hand, I'm using the median as a more robust central tendency here. And this interval, 2011 to 21, does include both the very high years of 2012 and 13 and the very low years of 2018, 19. So at least as a reference point for the modern ice thickness, it's probably reasonable. And you can see there a very low ice thickness relative to the 11-year median across all of Norton Sound, but also south of St. Lawrence Island and more mixed in the Bering Strait, but really not too dramatic. The thicker ice there in the north confined mostly to the central Gulf of Anadyr there. So the obvious question, of course, is why? Well, lots and lots of speculations about it, particularly from the communities. One thing we can say from the science side, there was a tremendous amount of east wind in the northern Bering Sea, especially Norton Sound, but really extending all the way to the southern portion of the Bering Strait region. The graphic here is just a plot of the east wind anomaly from Era 5 for the last 50 or 60 years, I'm sorry. And you can see there this past spring, this past February, March, the second highest east wind component in our record here. So really quite remarkable. And that had the effect of more or less continuously moving ice out of Norton Sound. And it would reform, but we had multiple strong winds event that kept the ice moving. There's a lot of speculation from communities because of the very early freeze up in November, or I should say very early relative to recent years. Autumn ice, of course, has a very strong trend, but this past November, Bering Strait South was either at or near the coldest on record across all of Western Alaska. So we had very early ice formation. Folks speculating whether warm air basically warm water got trapped underneath that early forming ice. Also, did we have something different with the currents? And was there something different with shorefast ice this past year? So I think there's a real interesting science question here. We had ice way far south. In the past, we would have thought that automatically translated to good ice conditions or thick ice conditions, stable ice conditions in the north, and that most definitively was not the case in the spring of 2022, and significant impacts to communities in the northern Bering Sea for sure. All right, so now turning to our August 22 ice in the Bering Strait. So we had ice from the northwest Chukotka coast that drifted southeast in the East Siberian coastal current in late July. It rounded East Cape about August 7th or 8th. The ice mostly remained on the western side of the Bering Strait. I can't quite figure out if it actually was seen from Diomede proper. It was certainly visible from the helicopter on approach into Diomede. From the air, it was evident to the west of Big Diomede. I'm not sure if it was ever visible from on the beach at Little Diomede. In any case, it was mostly on the western side of the strait. Did get somewhat far south there. Although it didn't get all the way down to New Chapelino, but it melted out there in about 3 weeks' time. So this was really interesting. And I should say again, I'm not certain of this, but my understanding is that there were definitely some and possibly quite a few walrus riding this ice. So that was a nice. That was a feature of this potential subsistence value to the Bering Strait communities. Here's the Weather Service sea ice program analyses here just to illustrate this. So you can see here on September 16th, the ice had cleared everywhere east there of Kolyachin Bay. And so looking like kind of fairly high ice there in the far western portion of the Chukchi, southeast of Wrangell for recent times, of course. But all in all, nothing too exciting. But then notice August 8th there, that ice has worked its way south in the East Siberian coastal current, and there rounded East Cape. And the concentrations and the quality of ice varied. It melted fairly quickly, but it lasted basically as long as there was a supply of ice that could be moved south. And here on August 25th, I think was the last analysis the Weather Service carried any ice in the strait. But it's a really interesting situation, especially I think mostly for its novelty, and it's because it's been really a long time since we've seen this. So again, question from the science side, why did we see this? Well, one thing we know for sure, early summer was quite cold across Chukotka. Here's the June, July low-level wind not rankings from the NSEP-NCAR reanalysis. And you can see there in the East Siberian Sea west of Wrangell Island there, we had anomalously strong north wind components, not record, but anomalously strong that kept ice along the shore and, of course, kept it cool in the early summer. Now, of course, one thing we don't know, operationally at least, is, was the East Siberian coastal current stronger than usual? Was there something different or dramatic in the freshwater runoff from the big Siberian rivers that in part drives that? So that would be an interesting thing to know. One thing to keep the ice in along the north coast, but how did we get? What was the mechanism that helped the current drive it to the south? So the short answer is I don't know when the last time we had ice in the Bering Strait in August was. Certainly not any time in recent years, but I'm not sure that we have the tools that can help us answer that. The passive microwave record is simply not sufficient to help us determine this. There's all, as most of you know, there's spurious, but low, but there ice detects in the Bering Sea all summer long. The operational sea ice index product always has some ice in the Bering Sea every day. That gets corrected out after the NASA bootstrap. But so I don't know when the last time this happened, but it's clearly been a long time. On the other hand, we know that this used to happen regularly and was a significant feature Sometimes the ice in August or September would drift all the way down to St. Lawrence Island. Say back in the 40s, I've heard Gamble elders talk about that. So in that sense, not a new thing, but certainly very unusual for the modern world. And finishing up with Murbach here, as most of you know, Western Alaska really badly hit by tropical ex-typhoon Murbach, formed very far to the east in an area that typhoons have historically hardly formed at all. The water in that part of the subtropical Pacific is historically not warm enough to support typhoon formation. It was this year. And the color field here on the graphic is just the ranking of the sea surface temperature since 1900. And you can see it formed in an area of in the top, basically top 10% sea surface temperatures, and moved across an area that this year is the warmest sea surface temperatures. Crashed into the Bering Sea just east of Shemya. And then once it got north of 60 North, weakened pretty rapidly. Unlike a storm, say, or later in the season, there was very little cold air to tap into as it across Northeast Asia as it moved north. So it weakened pretty quick. Before that, it was riding on the tropical air that had brought north, and ahead of right with Murbach there, Unalaska had the truly bizarre situation of temperatures in the low 70s at 10 o'clock at night. Once that tropical air got cut off, it weakened pretty quickly. Now, Murbach could have influenced sea ice, and there was a lot of speculation. Oh, what's this going to do to the sea ice? Here is on the left-hand side is the Environment Canada analysis from 4 a.m. Alaska time Sunday. A fairly deep low to the west of Point Hope there. Pretty good winds around that storm. But on the right-hand side is the Weather Service sea ice concentration analysis for the day before, and there wasn't really any significant sea ice remaining to be affected from this. The storm did not move much farther north than it's depicted in this analysis and weakened quickly. So while Murbach may have some effect as we go down the road, obviously, with the elevated seas and mixing from the storm that will influence upper ocean temperatures there in the Chukchi, but as an immediate effect on sea ice, it didn't have any just because there wasn't any to have. And that's reflected here in just the plot of the sea ice extent in the Chukchi. Murbach came right about at the minimum. Sea ice in the Chukchi is all very far north and close to nothing. So unlike last year, the green line there, return of the seasonally ice-free Chukchi. So that is, I believe, what I have for you. I think many of you are aware, but if you're interested in Alaska area sea ice stuff, in addition to the Pan-Arctic stuff that you're all familiar with, of course, the Weather Service does a daily sea ice concentration and sea ice stage analysis, 365 days a year. I produce those daily ice plumes every week. Every Sunday morning, I post those. I also post monthly sea ice comparisons from AMSR 2. And seasonally, we do annotated images, ice images, AMSR 2, the sea ice thickness stuff. Most of that's in the spring and early summer. And of course, many of you know or even involved with the ARCIS, the sea ice for walrus in the spring, which has lots of really great sea ice information, both from folks in the communities and from the remote sensing perspective. So that is the entirety of what I have for you.
Thank you, Rick. That was excellent. So now we'll transition to a longer discussion period. So if anyone has questions for Rick or Uma, now's your chance to chime in. We'll have about 8 to 10 minutes to discuss. So any questions? And I see there are some in the chat, so feel free to add more there. But Mike, do you want to ask your question out loud?
Sure. Well, what's on my mind now is Rick's presentation. So I've been involved with a couple of different field programs this summer in the Alaskan Arctic, and I've become a fan of those Alaska National Weather Service Sea Ice Desk products that you showed, Rick, and so can I do climate science with it? You got 30 years of that stuff, and that's part one of my question. Part two is, how does it relate to operational-ish products like those produced by the National Ice Center or MAISY or stuff like that at NSIDC?
Yeah, thanks, Mike. So I'm going to drop a link here in the chat. This is for AUS. They have archived in a GIS type format the Weather Service Alaska Region analyses going back to 2010. In general, so they're there. The Weather Service actually didn't start doing 7-day-a-week ice analysis until the early 2010s. Prior to that, it was a few days a week. Those are not online anywhere. There's paper copies back into the 90s at some point, in the office, but they're not, as far as I know, they're not scanned, and they're definitely not online. How does this relate to other products? So my understanding is that the Weather Service product is basically for the region depicted on those graphics. That is the input to the NIC and the MAISY products. So the Weather Service analysis, of course, is a multi-sensor, and it's basically whatever they can get, whether it's imagery, whether it's polar orbiter or SAR or whatever they have tools available at the moment to do the analysis they use. There's also policy issues that can affect the analysis. For instance, they kind of have a rule of thumb. If they don't know that something has changed, if they don't have evidence to point to it, they will leave it. And so often the analysis will be lagging from what you might expect otherwise. So there's those kind of issues. But at this point, what the Weather Service, the Alaska Region, is producing is an important input to both the NIC and the MAISY products.
Okay, so the arrow goes that way. The Weather Service product is produced there at the Weather Service, and then NIC uses that information. It's not the opposite direction.
Correct. Now, and I should say that is a relatively new thing, like the last 5 years.
Okay.
Prior to that, the NIC and the Weather Service analyses were independent. Independently produced, of course, using many of the same tools.
Okay, cool. Thank you.
Great. Jim, I see that your hand's up. Do you want to ask a question?
Rick, you want to guess on whether it was sea temperature was more important on the thin ice?
Yeah, Norton Sound is so shallow, it's hard to believe that there's, a reservoir of warm water sitting in there. On the other hand, we don't have any good measurements of it. So, like good scientists, we probably ought to try to do that. Certainly, as I'm going to give a lot of weight to the elders' comments, and when they're talking about it's been fall ice all winter, that means something. And I mean, the wind is clearly a big component, but it's not like it's never windy there. And this was at the high end, but I think there's something else going on. It seems like the water underneath would be the place to start.
I mean, that would be the I mean, the question then is, you know, the sea temperature would be a long-term background trend where the, you know, the wind would be more variable. So it's, you know, how locked in are we to thin ice?
Yeah, great question. And I think that's a really important one that we need to think about because it matters so much to the region. But, you know, from subsistence activities to the increasing winter maritime activities we're seeing in the region.
Great. Oh, there's one more question, and then I think we'll need to move on to updates. Do you want to ask your question, Wang Kui? You have your hand up. Yeah, there you go.
Sorry, that's me. Yeah, my name Wan Chiu from Climate Prediction Center. Speaking of impact of ocean, sea temperature, we recently carried out a few experiments using different sea surface temperature, and indeed it matters. We found that using austere CSST analysis to replace top layer sea surface temperature produced a much better forecast for week 1 and week 2. So this is for February experiments, but I think the idea is very similar for other winter months. Thanks.
Great. Thanks, Wang Shu. That's really, that's good to hear. And again, as always, appreciate you and your group's efforts at the weekly and seasonal ice prediction. Very important for us.
Thanks.
Thank you. So I want to bring it back to Uma real quick, because Uma, you and Mike were having a nice discussion in the chat about regional forecasts and perhaps giving more focus to that. Do you want to comment on those ideas?
Well, I think I was just, throwing out ideas. It could, and I know Mitch Bushek has a paper where he finds regional skill is higher than the Pan-Arctic skill. And so Mike outlined several things, and maybe it's you're limited to the possible outcomes, and that helps reduce the error. So I don't that, and that's an idea I threw out, and Mike had some other ideas that were somewhat along those lines, but I should let Mike speak for himself.
Well, I mean, I think that we started out with SIPN doing Pan-Arctic, and then there was this idea we should start thinking about regional prediction. And I think some people were like, "Oh, that's hopeless," because it's like it's just too small an area to get good statistics, or for whatever reason. But it turns out that's exactly wrong, maybe. So yeah, I don't know. It's interesting.
Yeah. Just I think we need to dig deeper on that.
Great. Well, thank you all for the excellent questions and discussion. So now I'm going to pass the baton back to Cynthia to see if there are any updates that people would like to share.
Awesome. So we have 5 minutes, but before we do the updates and announcements, again, thank you so much, Uma and Rick. Really fantastic presentations. Everyone, please, let's just give Rick and Uma a virtual round of applause. Okay. All right. So, okay, at this time, we'd like to encourage or open the floor for any announcements, updates from the community. Please feel free to raise your hands or unmute yourselves to share announcements, recent findings, ideas for collaboration, requests for future meetings. If you want to see other presentations, let us know, or anything you wish to ask or share. Okay, I actually have some announcements for the group. So IARPIC, the biennial implementation plan. So we're reviewing drafts and finalizing the drafts now ahead of the principals meeting, the IARPIC principals meeting, which is happening this Wednesday, September 28th. So the different agency principals are getting together, and they're going to talk about the IARPIC biennial implementation plan for the Arctic research plan. Another IARPIC event that is worth noting is the launch workshop for the biennial implementation plan. This will happen in Anchorage, Alaska, and online. This would be after AMSS, so early, January. And then lastly, I guess some of our Arctic has been getting a lot of attention in the Hill. As you all know, we had last September 20, we had an Arctic House Science hearing on amplifying the Arctic, strengthening science to respond to a rapidly changing Arctic. So this happened last September 20. And we had witnesses including Larry Hinsman, Mike Sfraga, Vera Metcalf, Susan Natali, and a recording is available in this link, and I'll put this in the chat. If you have time, please feel free to watch the recording of that hearing. Really fantastic hearing. And then lastly, another Hill engagement, the US House Appropriation Subcommittee requested for a congressional report on the Arctic Observing Network. So this report will establish and maintain the sustained Arctic Observing Network, including recommendations on the implementation and construction of such a network. So the report is being drafted now, just FYI, and it will be submitted to the House Appropriation by December 15. So you'll probably hear more about this in the coming months. But yeah, so lots of attention from the Hill. The Arctic is getting a lot of attention. That's some of my announcements. And in terms of CI's collaboration team activities, so our next thing would be we'll have a field operations post-field season meeting. So we had a pre-field season meeting last July and our post-field season meeting. So some of the activities happening in the Arctic now, some of the PIs will present how we can collaborate in terms of, how we share data and potentially other research as well. And this post-field season meeting is scheduled on December 8th, 2022. It's already in the IARPIC CI's collaboration team calendar. So if you're interested, this is open to the public and also will be recorded. So if you're interested to join, please, click there and attend. So those are some of my announcements. I'll open it for Melinda and Nathan if you have other announcements to the group.
No, but there is some activity in the chat by Alex. So there's a seminar link to click on and also a postdoc opportunity. So just check out the chat before you leave today's meeting. Thanks.
Awesome. Yeah, thank you, everyone. I hope you enjoy that. And we'll see you all again on our next CI's collaboration team meeting. Bye, everyone.